Now that we've talked about exponential functions, let's try solving exponential equations like 2 to the x is equal to 16. So this is a relatively simple example where you probably can just guess the answer, but this is really just to illustrate a strategy, a point to solving these types of equations. The base on the left is 2. Over here on the right, it's just 16. The trick to solving an equation like this is making the base on the left equal the base on the right. So the question you have to ask yourself is, can I write 16 as 2 to a power? And the answer is, well, sure, it's 4. So instead of using 16, I'm going to replace it with 2 to the 4th. I leave the left side alone. I'm going to write the right side as 2 to the 4th. And I have that the base on the left is now equal to the base on the right. The second this happens, you can just set the two exponents equal to each other. That is, x is equal to 4, which clearly is the solution to this equation. So again, very simple example, but illustrating a point. To solve an exponential equation, one approach is, can you make the base on the left equal the base on the right? And once you do, it's just a matter of looking at the exponents. Where are they equal to each other? So let's use this idea to solve the equation 2 to the 3x plus 1 is equal to 16 to the x minus 1. What value of x, if any, makes this thing true? So the trouble is that the base on the left is 2, the base on the right is 16, and those are not the same. But as we just saw, you can write 16 as 2 to the power of 4. So I'm going to replace this 16 with 2 to the 4th and see what happens. On the left, I'm going to leave that alone, but on the right, I'm going to write 2 to the 4th instead of 16. So this is a good first step. But now, I'd like to be able to equate these two exponents. And the issue on the right is, well, I have this 4 here, there's some parentheses, so it's not quite connected to this x minus 1. But I'm just going to use a property of exponents that says I can multiply these two things together. So we're taking it one step further. I'm leaving the left side alone. And on the right, I'm going to multiply 4 and x minus 1. Just being careful to say 4 is multiplied to the entire piece x minus 1, so I used parentheses. At this point, the base on the left is equal to the base on the right. I can now just take the two exponents and set them equal to each other. So that is 3x plus 1 is equal to 4 times x minus 1. We took an exponential equation and reduced it to a linear equation. So we have a strategy to solve this thing for x. I'll leave the left side alone. On the right side, I'm going to distribute the 4. To solve this for x, I will subtract 3x from both sides and add 4 to both sides at the same time. On the left, I get 5. On the right, I get x. And this is the solution to my equation. We could plug it back in to check to see that it's true, but that is it for this example here. So let's look at one more example. So here I have 3 to the negative x plus 2. Where is that equal to 1/9 to the x plus 1? So the problem here is, again, the bases are not the same. On the left, it's 3. On the right, it is 1/9. The question to ask is there a way that you can take 1/9 and rewrite it so it has a base of 3? Well, it has to be a negative exponent. A negative 1 here would take 3 and place it into the denominator. But negative 1 isn't good enough because I really want to end up with 9. I know that 3 squared is equal to 9. If I combine the 2 with the negative, I think that's the answer to this question. It's, well, 1/9 is the same thing as 3 to the negative 2. The takeaway is, if you see a fraction, I know we're dealing with some type of negative exponent. The negative exponent takes the base and puts it into the denominator. The second thing to do would be to square 3, which takes it to 9. I can now rewrite this problem. I'm leaving the left side alone, and on the right, instead of using 1/9, I'm going to use 3 to the negative 2. This. So I'm still not quite there. I mean, I'm good on the left. I have just 3 to an exponent. I have to multiply these two pieces together before going any further, so let's do that next. I'll leave the left side alone, and on the right, I'll put 3 to the negative 2 times x plus 1. Since the bases are identical, I can set the two exponents equal to each other. That is, negative x plus 2 is equal to negative 2x minus 2. To solve this linear equation for x, I think I'll add 2x to both sides and also subtract 2 from both sides. When I do this, I get x on the left and I get negative 4 on the right. And this is the solution to my equation.